Previously we completed chapter 3.1. Now we will start chapter 3.2, which is complete electrical circuits. So before we start this chapter, make sure you understand this and this is the math that you need, and you have already learned this. The unit of resistance is ohm, how to change the subject of a formula, how to solve algebraic equations using ratios, fractions and percentages, determining the slope and intercept of a linear graph. This is where you will be using this in this topic, that is to find the EMF and internal resistance from experimental results. So we will see the details. Now the first one, that is chapter 3.2 part 1, is about series and parallel circuits. In the O-level or 9 to 1 classes you would have learned this earlier, but this is also very simple. So we will see series and parallel circuits. Briefly we will go through what is there in this chapter. Then we will see electrical circuit rules, where you will learn the Kirchhoff's first law, Kirchhoff's second law, and you can also see a photo of him here. Then potential divider circuits. So from the name itself you can have an idea of what it means. Potential divider, it divides the potential. Then potential divider equation we will see. This is also very simple. Ratio and proportion mathematics is used here. We will see the details. Then potentiometer, I have already uploaded a video explaining in detail how to use this as a variable resistor, which is what you it's not here actually. You can also use this as a potential divider, so you can use it as a variable resistor. I have uploaded a video explaining how to use it as a variable resistor, and also you will use it as a potential divider. These definitions are important. And finally EMF and resistance. This is where you will have internal resistance. We use the simple letter R for internal resistance. Okay, there's another one, that is part 5, power in electrical circuits. You would have learned these equations in the O-level class also. Power equals energy over time, and also power equals work done over time, because work done is equal to energy transferred. Then using these two equations we can write this: P equals I squared R and P equals V squared over R. P is the power efficiency you have learned in the O-level class. And that will be the end of that chapter 3.2, and also it will be the end of electricity for AS Physics. So let's go to the beginning now. We will start with chapter 3.2 part 1, which is about series and parallel circuits.